Hi, I'm Tom and I talk about code. Welcome to another programming live stream where today I'm working on my compiler that I'm building in Rust. Yesterday I started doing work on better error reporting. I did a bit of work off camera, so I've got it building, the changes I started yesterday, and today I want to make the way errors get reported even better. Let's make a quick little summary of what happened yesterday and what the goal is for today, because it's kind of important. Stuff has changed since I last streamed this. So up until yesterday, I had an error type, let's call it E, that had some stuff in it. And it's one of the things it has in it is this an error in an if statement? Is this a while error? There's a lot of different kinds of error. There are a lot of different things this error can be. But one thing that was really hard is the way that the parser combinators work. You have this kind of list of things like parse an if statement, parse a while statement, ... and all of these things can fail. So you could have an error here, you could have an error here, then you could maybe have one that was okay, and then you could have another error. And it's like, well, okay, 3 of these 4 things failed. Well, actually, no. Sorry, if one of these things passes, it all passes. So if we have 4 errors as a result of this, which one of these is the error that we care about, right? We've got, this is also an E, it's just a poorly written E. Which one of these is the error that we care about? And so I came up with this system. I annotated my errors. So instead of just having a type E, I turn these into a confidence error. I'll just call it conf error for the sake of writing, which is a generic that wraps E, and it wraps it it wraps an extra bit of information, this information being confidence, which can either be low, medium, or high. And this represents how confident we are that this error is the cause of the cause of the failure, the overall failure. So if we have a list like this and only one of these things has high confidence, then we can be pretty sure that that is the thing that caused the failure. An example of this is that if we're parsing some code, if we have some code, for example, if foo ... and if, say, we delete one of these braces, because we've already seen an if by the time we get here, we've seen this if. We know that we're deeper into an if statement. We're pretty sure that by the time we do this, the problem is actually in parsing an if statement. So everything that comes after an if in an if statement, that's a pretty high confidence error. That we're fairly confident that this is the thing that, look here, look at this thing as an if statement, consider this as an if statement. That's why this thing failed. So that's the idea, and that kind of works. Let me demonstrate how this kind of works. So if I open up, let's look at test.code. I think, where are we with this? This looks good. So if I compile this, bin lang test.code, awesome, that builds. And I mean, it just dumps a literal binary out into the terminal, which is kind of fun. Now let's go into this while statement, and let's, like I did just then, get rid of one of the brackets. Well, what error are we going to get here? It's going to say, hey, there's an error in the while statement, because in the code, in our statement while, we see that when things go wrong after this, we actually, I don't give them back as a high confidence. I use this concept of elevating. I say that whatever confidence we have of this thing, elevate it, make it higher confidence. Now, it might be better to actually say, just max this out. Maybe I need a function called max. Maybe that makes more sense here, because in this case, we've seen the token while. Everything after that, we're very, very confident that this is part of a while statement. But this works. This works. This gives us a lot better results for the errors, but it's still not perfect. One of the reasons that it's still not perfect, and that's not as far as I meant to jump down the page, one of the reasons it's still not perfect is there are lots of things that can fail. Let me show another example of this. Let's delete a semicolon in our main function, and let's see what it says now. Well, it still works out that it's in the main function. It still says, hey, yeah, it's actually at this exact statement here. But because of the way we print out the errors, it has to print out the rest of the state as well. Because the way our parser works, it consumes a bit of the text that comprises our program, and then the result of that is a thing and then the rest of the text. So as far as our error is concerned, all of this is relevant. And that's not good. That's not right. That's not how we want to think about this. We probably want to be able to break this down into, say, functions, so that we could say, hey, in this one function, this error occurred. And maybe there'd be an error in another function as well. So maybe these structures need to consider functions, need to consider function by function. And how we do that is actually kind of hard, because that means that even from an error, we need to advance the state. We need to find a way to walk to the end of this function even though something's gone wrong. So the level at which we do that is very, very tricky. Very, very tricky. And there's a couple of ways we could think about it. There's a couple of ways. The most naive is to just scan for a closing brace, right? But that doesn't necessarily work, because we could have an if statement in here, right? That would break the concept of look for a closing brace. So we could say look for a balanced closing brace, right? Every opening closing brace that isn't in a string, let's pretend strings can't have braces in them, we'll include that as some kind of technical debt. But you have an opening brace, you need to see another closing brace. So you count how many opening braces you see and how many closing braces you see, and when you see an unbalanced closing brace, that is the end of the function we're in. As long as we made it past the first closing brace in the function, that is, that's an option. That's an option. The problem with this is how we actually communicate that back up, because when this fails, let's go for function definition. It fails, so we're in this situation where parse type, identifier, parameters. So when this bit fails, then what? We need to tell it. We need to return an error that knows how to advance just through this. So this is really messy, and this the more I'm talking about it, the less confident I am that I know how to solve it. But we can give this a crack, because this is really important. The way errors look right now is just extremely jank, and it would be good if they were better. It would be good if they were better. So I guess there's two schools of thought, right? One school of thought is and the two options, and these are the things I'm weighing up in my head as I speak. One is chunk the file into top level elements. For example, function definitions, and then handle those individually. That would work. That would kind of solve this, and that would give better errors. Then you'd get that nice kind of list of errors, C style. Two is try to persist after an error. Maybe not even consume to the end of a function, right? Maybe if this line is bad, we just keep going. We just try and do the next expression. Maybe we can build a list of failures, again, maybe within a function. So in this case, that would mean that in this repeat one, we say repeat one, but hey, it's possible that there will be errors. Now, the hard thing about that is we'll try to parse the closing bracket, and that will be an error. That won't be a valid expression, but then we'll just keep going, right? We rely on the expression parser failing to tell us that, try and stop doing expressions now. It's time to end the function. It's time to consider ending the function. We rely on that. So that also probably won't work. So this one's actually tricky. This might actually be more than I can chew off, more than I can bite off today. What's the simplest thing that I can do to persist after an error, right? What do I do? And it probably happens here, right? Where I return this out. I wrap. Yeah, so it's wrapped in an open and a close. For one thing, what is the error that can happen here? Well, the error is that it expected, and this is exactly what we're going to see if I run it, it's going to say it expected to see a closing bracket, because after the first expression fails, we expect to see a closing bracket. That's exactly what we say. So how do we even start to unpick this? Well, this wrapped abstraction plus this repeat kind of make this impossible. It kind of makes this impossible. And that's bad. So what would an abstraction look like that allowed us to continue? Oh, oh, it's just really hard. It's really tangled up. It's really, really tangled up. Huh. Okay, I had a vague idea that I was gonna do this, but this is hard. Maybe I'm gonna have to. I might actually like literally have to move on to a slightly different version of this. A slightly different version of this. No, but I can't even do that. I can't even. Okay, I've got some regrets, and this is the hard thing because I'm winging this whole compiler, but I've painted myself into a bit of a corner with this. Ooh. I might have to park this one. That was a good little bit of brainstorming, but actually all of those threads were dead ends. And they're dead ends because the way I detect the end of a function is the thing is not a statement, and then I try and parse it as a closing bracket. And if that passes, then all of this passes. Otherwise, it's this error. So I rely on failing to parse a statement to then detect the closing bracket. I don't preemptively look for a closing bracket. So I guess we can rewrite this actually. Let's try this. Let's try function body. Let's try and write this as a parser that we have a little bit more control over. We'll return a result again as something that returns a top level element. Actually, not a top level. We're going to do a vec of AST statements, I guess. Okay. So the first thing we want to do is to grab a skip white space token, right? And so instead of using this wrapped structure, we're going to try to preemptively look for the end of a function before we look for an expression. So we'll put a loop here. We'll say loop. The first thing we do is, this needs to be mutable, doesn't it? Let's say let mut, I think I can make this mutable. We'll call it head. Let s, let's call it sx blank equal wait, I want to maybe match, because this is a result, right? I don't want to question mark this. I want to unwrap this myself. So let's say match skip white space token. So with the first thing we try and do, now instead of trying to do this last after we've failed a statement, let's try and preemptively do this. Let's try first. Can we get a closing token from the head? And that's the correct number of parentheses. If this is okay, and we don't care about the thing that's in it, then we're done. We need to make a mutable output, which is going to be just our vec. We just return out. That's all we got to do. If we get an error, that's where we then try to parse a statement. Okay? So this is critically different. This is critically different because it will, instead of forever trying to parse a statement until a statement fails, then looking for a closing curly brace, this looks for a closing curly brace first. So the failure of a statement now means that there's not a valid statement, right? If we don't find the end of the function definition and we find something that is not a statement, we know we have an error local to that function. Before, if we had an error trying to parse a statement, that could either have meant there's an error in the statement or we've found the end of the function, right? We've split this out into two separate cases. We know what this error means much more precisely now. There's a much more precise reason for this error. Cool. So now we need to try, let's say, statement terminated. Let's match again. I don't like nesting matches like this. I think it's actually hideous, but let's do this again. So statement terminated, we want to skip white space here to statement terminated. and we want to do that at the head as well. We want to do that at the head as well. Except also we're not returning out, are we? We're returning okay. We're returning the new head after this token and then the out. I forgot there was I forgot this was a result for a second. I forgot there was extra context we needed. This is the whole point of the parser combinators. Extra context that we needed. Okay. So we've got a match, and again, if we match with a thing, let's call this our statement, then we want to say out.push statement, and we want to let the head be equal to whatever the result, whatever the new state is after this pass. Okay, if we get an error, this is where we want to actually return that error. Cool? Does that sound good? I think that sounds good. I think that sounds really good. And this loops forever. Eventually, one of these is going to fail as long as, our input isn't infinite, which we have the same problem here. we have exactly the same problem here. Okay, so let's try and use function body like this. Let's say let's try and use function body, and it takes s4, and we're gonna unwrap it like that. Excellent. Okay, is that it? Is that what we do? Build? It's gonna yell at me. Of course it's gonna yell at me. This delimiter might not be properly closed. Cool. Unexpected closing delimiter. That's fun. You don't usually see that one. That is unbalanced somehow. That's balanced. Oh. Actually, I think I just want to wrap this all in curly braces. I think that looks clearer. Okay. So we have an unused thing, and that's actually a really scary prospect. Because when one of these is unused, it means that we're not advancing our state properly. So that's a really good error. That's a very useful error. All right, cool. Let's see if all our tests pass. Apparently they do, so that's nice. What happens if I build this now? Expected token semicolon. Like this is actually, this is exactly the correct error, which is cool. This is the exact point that the error happens. It's at the start of this line. So this still isn't perfectly clear, but it is actually now honing in on the exact moment that error occurs. And it knows that this is the most significant error. Cool. So that's kind of nice. So now we have this concept of consuming a function body and pinpointing the exact error inside of that function body. Does this help us to consume the remainder of the function in case of that error? And the answer is a definite maybe. The answer is a definite maybe. Maybe counting brackets is the way to go. Let's try and write this function. Let's say skip function body. And this is going to just give us back a stir, right? It's going to give us a slice in a different place. So we'll say let mut head equals 0. Let mut brace count equals 0. For I in 0 in, I guess we don't need head, input len. So for every index in this input, right? For everything in this slice, we'll say if input.get if let sum no, actually we can match input.getI. We can match input.getI, and we can say sum opening curly brace, and then we say brace count plus equals 1. If we have sum closing brace, we have if brace count is 0, we return input I dot dot. Can we slice like that? I think we can slice like that. Maybe we need a bound as well. Maybe we need to say input dot line. Let's try that. And I don't think we necessarily need a semicolon. Else, otherwise we brace count minus equals 1, right? So we start at 0. When we see an opening brace, we increment. When we see a closing brace, we de-increment. But if we're on 0, that means that we've found the end of the function, I think. What are we going to call this on? We're going to end up calling this... Does this mean we're going to see an opening brace? Maybe I need to actually... Let's do it like this. If brace count is less than or equal to 0. Okay, because we're going to see an opening brace as well. Cool. And we also kind of need to think about string. Well, we don't have strings in the language, so it doesn't matter. So this will work for now. But, and I keep saying strings. I keep not really explaining why. But let's say we have, let's go into test.code. And let's say we have a syntax error in this function, as we do. So then we want to go back and take this function and consume it to the end. And let's just say, yeah, like skip over the rest of the function. Or do we, or do we keep running the parser? Oh, it's hard, right? It's hard. Maybe like from the next line, continue running the parser. Maybe in here, right? Maybe we have a vec of errors instead of just one. Maybe we... Let's try this. Let's keep pulling this thread, right? Because this idea of being able to continue on inside the function body is pretty powerful. It's pretty good. Because then we can get to the end of this and be like, okay, we've got errors. But how do we know when to stop? We know when we see this, but what if the function is unclosed? So, This is dangerously close to an infinite loop. This is really dangerously close to an infinite loop. What I'm kind of saying is when we have an error, instead of just returning it straight away, what if we advance to the next new line? And then we still need to find... So I guess the thing, we need to look at what the error actually is, because if we look at the error, one of these errors eventually gets into like, you know, just the input ended. That's kind of significant. We don't really have an... Oh no, yeah, we have parser error kind end. We have an end of input error. So maybe I could look for that. Like if we get end of input, then that's one thing. Otherwise, if it's any other error, we just power on. we power on through. Let's try it. Let's before I start doing this, let's get rid of skip function body. I think that's a dead end. I think that's a really dead end. So cargo T, everything works. Let's add lang source language, and we're just going to commit this. No, we're not. Because of something very clever I did off camera, I now run a pre-commit hook. So if I look at git hooks pre-commit, I run cargo format quiet mode, and just in check, like don't actually commit any of the changes. If there are things, report it to me and exit. So now I know that I need to run cargo fmt, which modifies this file. I'm going to add it again. I can look at the differences. I don't know, I'm guessing it re-white spaced this or something, or maybe a character at the end of the line. I'm not sure exactly what changed here, but it's relined this as well, which is cool. it got rid of my extra curly braces that I thought looked good. Interesting, controversial decision there. Very controversial decision there from cargo format. But this is good. This is good. So we'll add lang. We'll commit it. Lang source. Function body. What does this do? This tries closing curly brace first. That commit message won't mean anything to me in the future. Muhammad OXF, why not formatting on save? Yeah, I could. There is really no strong reason either way. As far as in a pre-commit hook, I prefer that it reports to me to run a tool rather than automatically running it. But honestly, it's just because, you know, sometimes when you format on save, you save and then stuff jumps around on your screen and you don't always want that. Sometimes I like stuff to just stay where it is, you know, especially in Rust sometimes when I'm writing something out. Like, I've put stuff in a specific place, and when I save, I don't want it to jumble all my match statements up. Like in that case, I think that's actually a pretty good case. If I go to function body, like I've got a nested match, and when I was writing it, I thought it looked a lot clearer on this line. But if I have format on save, when I save, it would get jumped up to this line, and I find that kind of thing really breaks my flow. So I like these tools to be things that I run, but once I'm done with that initial conceptual phase of coding, that's when I want them to run. So it's opinionated. If you like format on save, use format on save. But for me, I just find anything that happens automatically, I guess, or like when I haven't explicitly triggered it, I find it kind of annoying. That was a long-winded answer to a very simple question. I'm sorry. Okay, wait, let's try and give back a vec of errors. This is going to mean doing more complicated stuff here. So first things first, when we find the end of the function now, it's no longer in simple. We want to say if error.isEmpty, then we just return, we just return whatever state has advanced. Cool. I guess the tricky thing here as well actually is in this error state, we don't give back the new head. So how useful is it giving a list of errors back? What can you actually do with those? Or do I just accept that this is a compiler that kind of gives errors one at a time? Right? It's like, hey, here's this one error, fix it and we'll give you the next one. Maybe that's the workflow for now. Maybe given how unprepared I was for this stream, maybe this is already a good outcome and I should just take my win while it's here. What did I say I was going to do? Better error reporting. I said I was going to clean some stuff up. And honestly, this is probably more approachable in the scope of a single stream. So maybe this is a good one to do. Maybe this is a good thing to do, where if we look at our statements, terminated, we have this function. We have this function called statement terminated. And what this is a statement and then a semicolon, which sounds fine, right? But there's a problem. And the problem is, if I look at test.code, our while is a statement. So while has to end in a semicolon. And that's actually not right. That's very much not correct. So that sucks. Let's not do that. Let's really just not do that. Okay, so where is statement used? Statement only appears in statement terminated. Oh, some statements are semicolon terminated. In fact, they all are, except for while and if, in the context of a function. Do statements exist anywhere else? No. So should these just be... Should these be part of the statement? I don't like them being part of just the parser. I feel like I want them to be wrapped up somehow. Now, what I can't do is make a function. Here's what won't work. This thing that I've tried doing before, where I say semicolon terminated, which would be a function that takes an input and gives us back a C result, which has some stuff in it, right? Just some function here. No, sorry. What am I saying? That's not this. I want this thing that takes in a parser. I want it to take in, let's call it an F, and to give back a function that gives back a C result. A C result where it's a parser of stir, AST statement, and why am I writing all this out if it doesn't work? Well, it's just good to demonstrate. So basically taking making a wrapper where I could say semicolon terminated, right, and say this has to be semicolon terminated. Unfortunately, this won't work because this type cannot be because of how because of how closures work. This type can't exist in this vec with other things. It breaks. These two things can't live next to each other in a vec. So one option is I just make it part of this parser, and that is sounding more and more tempting the more I think about it. I don't think there's a downside. I don't think these statements ever exist without a semicolon coming after them. This will break tests, but maybe this is what I need to do. Maybe this is what I need to do. Variable assign. Let's do it. Let's do it. Skip white space token. And then we get S3 here. And oh no, we've already elevated our confidence. So actually, we need to elevate the confidence here as well. We are more confident at this point what this error was. And we're just going to copy and paste this a little bit. So this goes in dref assignment. This goes in dref assignment. We need S1, S2, this manual monad is a little bit of a pain in the ass, but that's okay. We will survive. This, when we declare a variable, we need it as well. Oops, this has to get copied. And then this this becomes 4, this becomes 5, and this becomes 4. There is unfortunately no good automatic way to do this. This is a very manual refactor. After a return, we need a semicolon as well. S1. This is so prone to error. I am almost certainly going to do it wrong, and that's okay. If does not get a semicolon. I forgot if was like this. While does not get a semicolon. Continue does get a semicolon. Now we need to actually store the result. So we can say let so res equal this, and then let s1 equal this, and then we say okay res. Okay, S1 res. Beautiful, beautiful. And I like this. You know, we have a token, we ignore it, we map it out to continue. Break, we're going to have the same thing, because these are basically the same thing. Yep, equal this with a semicolon, and then this. Expressions are going to get it too. Excellent. Okay, so we did it for this, we did it for this, we did it for this. Let's build this and see what goes wrong. Just some stuff I didn't clean up. That's good. When I test this, however, it will yell at me. It will yell at me. And it's kind of fun, right? We can see in these tests, it's like, hey, something's wrong. Something's wrong. So, function body. Tests failed, function, test assignment. Okay, we basically just have to go through these tests and find the ones that have statements like this, statement blah blah blah. Just needs a semicolon. Assign dref, this one needs a semicolon. This one needs a semicolon. Semicolons for everyone. Semicolons all around. Test declare, yep. Semicolon. Believe it or not, this one also is This one's okay, actually. I think this one's okay. I think it said this one was broken, but this should be okay. This should be okay. Return. I think I did it for return. Interestingly, if the if test never had one, of course it didn't. Okay, well let's test again, see what tests break. Assign deref. Assign deref fails. Yes, now this is interesting. This is because when I print these out now, they should actually have the semicolon attached. They should really have the semicolon attached, because, and I'm going to have to change a little bit of extra printing logic for the function body as well to no longer insert these. If statements don't have it, while statements don't have it, break, continue, and expression all have the dreaded semicolon. Okay, so now I just need to do the function body. When we display a function body, we get the args, we get the things, body, iter, collect, join. Collect, yeah, this. I need to get rid of this bad boy. All right, inline ASM is fine, global variable is fine. And this looks good. Like, even though it's wrong, it looks good. So it says here it expected a semicolon, and it did not find one. So here at a equals 99, and this is in language test 494. So the error was here. It didn't find this, which is interesting. Function definition. And that's probably because I did something really silly. It's probably because I did something really silly, and I'm still parsing statement terminated, so it's looking for 2 semicolons in a row, which is too much semicolon. It is in fact too powerful. Yeah, cool. Statement. Okay, so we're gonna build this, and something went wrong. Statement terminated. It doesn't exist anymore. Statement terminated is dead in the water. They're just statements now. And while is going to have the same problem. Statement terminated. They're all gone. Beautiful. Test. Beautiful. We're making progress. Okay, so again, we've got some double semicolon in formatting. And I know exactly why this is too. It's because when we print out if statements, we are doing the same thing, and the same thing for while statements. Cool. So now if I test, it'll work. It just works. Like I said, it just works. No problem at all. No other forgotten semicolons. No other things that can go wrong. And this time it just works. Almost. Is that because we didn't put it in the printout? Or is that because assign deref? Expression has it. Okay, so let's go back and look at what is actually failing here. Left equals right fails language 463. We have foobar exclamation mark. We have expression deref. That's because this is an expression, not a statement. This continues to bite me. I don't have Bobbius here to tell me what's up with this, which is he's been saving me with that the last few days. Okay, soft multiply fails. Yes. This is good. This is very good. Compiler test. No. Yeah, this one. Soft multiply. Because this should now be superfluous. This should now be completely unnecessary. And this is good. Okay, so we're going to go to our test branch, lang tests conditional. We want to get rid of all these semicolons at the end of our if statements, which is insane. These have been bothering me for so long. This is the most satisfying change I've ever made to any code I have ever written. Lang tests pointer. I don't think we have ifs here. If, while, no. Okay. Lang tests. Loops, however, will have them because of the whiles. We just get rid of these. Oh, beautiful. It is actually a thing of beauty. Okay, recursive calls. That is also fine. We want lang tests, functions, A, B, C, D. Recursive calls breaks because we have an if. This is so good. This was a good day. Okay, so let's just double check. Cargo T, everything passes. We'll do a cargo FMT just to preempt what's going to happen. Let's look at the diff and see what it reformatted for me. Put this on one line without a brace. I guess that's okay. It is only one thing. Cool. So what did we do? What did we do? We lang. We simplified state. We removed semicolon from if while. They no longer have semicolons. Oh, I'm still on a random branch. Oops. That's okay. We're just going to merge noFF into main anyway, so that's all good. That's all good. That's pretty good. That's pretty good. I'm feeling good about this. The language is just looking better. Now, there is one test case that I noticed the other day that does break. So let's write a test. Let's write a test. While I'm doing misc cleanup, let's write a test. We'll copy paste. Let's call this code after while. And what I found was, I was trying to write some code, and I'm going to try and replicate this as closely as I can. Maybe maybe part of the problem with globals as well. It turns out there were some problems loading globals in the web UI. Kind of broke some stuff, and I fixed it. But it's a bad fix. It's bad code and it's a bad fix. Okay, so we're gonna have this little branch, this little loop, right? And we'll have a loop on the inside as well. So let's do almost exactly what I was doing there. So we'll have an A and a B and a C. While B less than 40, C is C plus 1, and B is going to be B plus 1. Okay, but then after this loop, we're going to say A equals A plus 1. And then return C, yeah. Cool. So, what should C be? C should be 39 plus 39, which is 78, you would think. But I think it will not be this. I think it will be distinctly not 78. And this is fun. This is good. this is awful. This is like the worst kind of thing to troubleshoot. And the problem is that this line never gets executed. And I noticed this because I was trying to draw stuff to my virtual screen, and it like I was trying to fill the screen with lines, and it just wasn't happening, right? The lines were not lining because like I was only getting one line because this what's happening? Oh, like I don't actually know. That's not right either. But it was only happening once, right? So while A is less than 40, like you would. Oh no, hold on. This was this thing again. This is this thing again. Never. What was happening in my code? The problem with my code is once you say I can make this break. I can make this break. 1600 40 times 40. Yeah, hold on. Wait. Because I'm doing that 40 times 40 times. Yeah. I can make this break by saying global int weird. Okay. So the thing is I think labels get broken by globals, but maybe this only happens in the web version. I feel like I need to show this now. I feel like I need to convince you that I understand how to write a while loop, because I didn't in that other episode, right? in you know, like a week or two ago, I already demonstrated that I struggle to write while loops with this exact line. But let me run the server. http.server Oh, wait, I'm already running it. I'm still running that from my last stream. Actually, from who knows how many streams ago. Okay, so let's grab this code into test.code. Actually, let's just modify this because... No, okay, hold on. Let's go to test2.code. The other test.code. And we'll see this do something a bit funky. Yeah, so cargo r bin lang test2.code. Disassemble this and then copy it. Which is we end up with a different number in A, right? We end up with a weird number in A. This, I don't know, something weird happens, right? Something weird happens when you run this in the browser. And I think I might have almost fixed this. And I might actually have to go and do some soul searching and offline work to make this work. But I think next stream, potentially, if this does actually work, if maybe this was just weird global label offset problems, maybe I'm glad I have a test for this because I thought this was wrong, but I suspect it's actually just whatever the hell's going on here. And I might have actually... I made some inroads towards fixing this. I rewrote some of the preprocessor on my laptop. I haven't merged those changes in on my PC yet. But I can do that. I can do that off camera, and then I can hopefully write some little graphics visualizations for the screen, because this language is feeling pretty... It's not complete. It's not good. Type inference is probably actually the next big thing I want to tackle, but it's capable of writing complete programs, I think. It's time to start making... Oh, no. Sorry. The other thing I'm missing, and this is also going to be a big one, are strings. So there's a lot of fun stuff to look forward to. So this has been a very odd and very fun stream. I hope that everyone watching is having a good time. Bit lower energy for me today. A bit more tired, a bit more chill, but that's okay. That's okay. I'm still trying to save money for an HDMI capture card. If you are enjoying the show, feel free to donate on through. I really do appreciate all the people watching on YouTube and leaving really helpful comments. You guys are amazing. But I kind of did this. Let's give this a kinda. And clean up statements. I definitely did that. But this gets like a squiggly line for kinda. This is gonna take a lot more thought than I realized. Wow. But yeah, that was kind of fun. It was fun to dive in on a stream and talk about my thoughts. And again, I'm enjoying that people are feeling like they want to help out and leave me good comments. If you think this virtual machine looks interesting, you can actually go to my website right now. You can go to coding.tommarks.xyz. You can go to projects. You can go to where I started this in 2023, even though I'm pretty sure my first commit's in January of this year. For some reason, it's in 2023. And you can try it, the live version on my website. It's pretty much what is in main. It doesn't auto-deploy. I have to copy a folder into my website, but that's okay. So go play with it. See if you can write a cool program. There's a really cryptic help page, and the repo has all of the opcodes in it. So yeah, I proofread this. I made some changes because they were incorrect, but now they should be correct. So if you want to try and write some code and interpret whatever the hell this means, this is just a stack. That's fine. This is the bit that's it's a bit quirky. The whole ASA is a bit quirky. There's no hardware multiplier. You've got to write a subroutine for that. Okay, I'm rambling now because I'm tired. Thanks everyone for tuning in. Enjoying this project a lot. Enjoying the people tuning in a lot. Thank you very much. I'm Tom, and I'll catch you next time.